Good afternoon, everyone. My name is Alicia Cortez, and I'm a project scientist at UC Davis with the Tahoe Environmental Research Center. And as I mentioned in a previous talk this afternoon, I would like to provide a brief overview of a partially funded project by CNRA, which is titled Hypolimnetic Oxygenation Pilot Project to Rehabilitate Clear Lake in the Oaks Arm. So first, I would like to start describing what is this technology about. So hypolimnetic oxygenation, or HO, consists of the direct addition of very fine bubbles of pure oxygen to the bottom layer of water of the lake, which we normally call hypolimnium. So the pilot project that we have recommended for Clear Lake is going to be focused on the Oaks Arm, which covers 10% of the total lake surface. So I would like everyone to keep this number in mind, that our pilot project will be able to treat 10% of the lake total surface. So to give you an idea of how the different components of this kind of technology look like on the ground, here I would like to show you some on the ground photos from an HO system that we visited recently in Lac Loma in Santa Cruz. And these facilities were installed by Mobley Engineer. So essentially, the HO component on the ground consists of a liquid oxygen tank, like the one that you can see on this photo, connected to a vaporizer that essentially converts the liquid oxygen into gas, and then a pressure control panel that regulates the pressure of the vapor of the oxygen, which will be added to the lake through a set of diffusers, which are connected to the underground component via all these pipes. So this is essentially the underground component that we saw in Santa Cruz. But here in this map, I would like to show you a tentative design of how this hypolimnetic oxygenation system could look in the Oaks Arm. And I would like to say that this is only a tentative design because part of the project that we are already funded to do is to fully define the finalized design of where the diffusers and the underground components will go. But so far, I would like to thank the Clear Lake Oaks County Water District, who have been very receptive and willing to discuss with us the possibility of having the underground components on their facilities. So thank you for that. And also in this map, I would like to indicate that a potential location for the diffusers that bring the oxygen down to the bottom of the lake could be essentially around the deep hole in the Oaks Arm, as I indicate by these red lines. So a little bit more details about the diffusers are shown in the diagram that you can see on the right, which are essentially showing that the system is simply is formed by a set of pipes which are transporting the gas of oxygen to the bottom of the lake and then diffusing the very fine bubbles of particles upwards, maintaining always a certain distance with the bottom of the lake. So moving forward into describing this project, I would like to mention that the targets to consider this project successful are essentially having two main metrics, which are maintaining the oxygen concentration about 3.5 milligrams per liter, so essentially breaking these low oxygen conditions or hypoxia that I mentioned in previous talks. And the other main target is achieving a reduction in phosphorus concentration in the target area of between 20 to 50%, compared to the values that we would expect under anoxic conditions. So as a result, our monitoring will be tracking the concentrations of these two constituents, but also we will monitor other variables such as methyl mercury concentrations in collaboration with USGS, phytoplankton community, and cyanotoxins. So overall, our main goal during this pilot project is to be able to fine-tune the oxygen injection strategy. So essentially, we want to answer these questions that you can see here. How much oxygen we should add? So essentially, we could add a lot because that won't hurt the system, but that could waste funding. So we want to find the sweet spot. But we also want to know when we should start the injection and for how long. And this is something that we are going to do following a very strategic plan in which we will combine the predictive tools that I have been also describing during this symposium in combination with a real-time monitoring system, such as the one that you can see on the diagram on the right, with a buoy that is connected to a cloud, sending data that we are measuring real-time for oxygen and temperature at the bottom layer and also at the surface layer of the lake in the Oxarm. So previously in the session today, I talked about modeling tools that we have developed for Clear Lake. And here I would like to show you how we use those tools to essentially design how this HO system should be looking for the injection in the Oxarm. And here what you can see in the video that I'm going to play in a minute is essentially two different scenarios. So in the top, you are going to see the bottom oxygen concentrations in the Oxarm, in assuming that we are not adding any oxygen to the bottom layer next to the sediment. Well, at the bottom, you will see a scenario in which we are adding oxygen to the bottom of the lake, particularly in the deep hole of the Oxarm. So please, I want to mention that high oxygen is blue, low oxygen is red, and you're going to see how the concentrations in the bottom are going to be changing over the course of 2-3 weeks. So as I play this video, you can see that shortly after a week since the dissolved oxygen injection started, the bottom of the lake became fully oxygenated for the case of the scenario in which we had oxygen injection. And overall, at the end of the simulation, you can see that we achieved values of oxygen about 3.5 milligrams per liter, which was our target, for at least 90% of pacing. So here in this other slide, I would like to again look at modeling results, but from a different angle. So here what I'm showing is model time series in depth of lake temperature at the top, dissolved oxygen concentrations in the second panel, concentrations of SRP of phosphate in the third panel, and finally phytoplankton concentrations at the bottom. So the two columns are showing results for different scenarios. So the column on the left is showing results when we are not having oxygen injections, while on the right, we are having oxygen added to the bottom of the lake. So as you can see, looking at the temperature, the dissolved oxygen injection didn't change the temperature, but it dramatically changed the oxygen concentration at the bottom of the lake. So we can see how adding oxygen kept all this concentration of this constituent about 3.5 milligrams per liter. In fact, we reach values of 5 milligrams per liter, which is good for all the problems that Clear Lake is having. And in terms of the impact of the SRP, you can see that when we are not adding oxygen, we achieve maximum values of SRP of 700 milligrams per cubic meter. But when we add oxygen, though that concentration was down to only 2 to 300 milligrams per cubic meter. So essentially, we achieved the reduction of XRP to half compared to the control scenario when we are not adding any oxygen. And finally, the phytoplankton concentration dropped from having maximum values of 1,500 milligrams per cubic meter down to 1,200 milligrams per cubic meter. So essentially a reduction in phytoplankton concentration of about 20%. Looking now a few more plots, which are also results from our simulations. Here, what I would like to show you is model results time series of different constituents that we average across the whole basin and in depth. So essentially, you can see time in the x-axis and the concentrations of dissolved oxygen, SRP, and phytoplankton carbon in these three subpanels. And the different colors of these wiggly lines are showing the results that we would obtain for different flow rates for our HO system. So here, what I would like to show is that when we are not adding any oxygen, you can see the drawdown in the mean average concentration of DO, both in depth and across the basin, which triggers the increase of nutrients and also the rapid increase of phytoplankton concentration. But when we are having a flow rate of 500 cubic feet per meter, we achieve the reduction, we achieved the targets that we were looking for, which is maintaining the DO concentration, the dissolved oxygen concentration, about 3.5 milligrams per liter, as you can see in the red line. The reduction of phosphorus concentration to half. You can see that by comparing the blue to the red line, which is the control scenario, no flow, versus the scenario in which we are adding oxygen to the bottom of the lake. And then you can also observe the reduction of 20% concentration in phytoplankton when we compare the blue and the red line, which is no flow versus a flow of 500 cubic feet per minute. And then for this other slide, I wanted to show you a scenario in which, now that we have proof that this HO system could be successful while treating 10% of the Clear Lake area, which is the ox arm, we ran some model scenarios in which we were trying to test how we could use HO to treat the whole lake. And that essentially would be achieved by using multiple diffuser lines. And here in this example that you can see on the right, you can see the bottom concentration of dissolved oxygen across the whole lake in the middle of the summer of 2022, when we didn't add any oxygen. And at the bottom, you can see how the bottom concentration of dissolved oxygen would look like when we have a total of 6 lines of oxygenation, 1 in the ox arm, 2 in the lower arm, and 3 in the upper arm. And I want to highlight that these lines were able to oxygenate the bottom of the lake completely, which is the area that tends to be anoxic for most of the time of the year. So the exact location of these lines would be something that will need to be designed under future funding, but this is just a promising result and also a proof that we can use the tools that we have developed to Clear Lake to test restoration strategies. So here in this other slide, I would like to show a tentative timeline for this project, which also I would like to mention that relies on funding availability. So first of all, thanks to the funds that CNRA has already granted to this project, we would like to conduct the first phase of the project, which is essentially the planning phase. We're expecting to start in October 24, and this phase will last about a year and a half. And the main tasks of this initial phase will include the design, as I mentioned before, knowing where the on-the-ground and the diffusers are going to go in the Oaks Arm, the permitting phase, also community engagement. We are planning to engage with Lake County and the tribes. And finally, a monitoring phase to gather information of the pre-injection conditions. So before adding oxygen, how the lake looks like, and the things that we would like to modify during the injection. We are also expecting some extra funds from US EPA to be sure that USGS can measure constituents, which would be also very important, such as methylmercury. And then on the second phase, which is still pending on funding, but I would like to mention, and probably some of you already hear US EPA Carter Jessup, program officer, who mentioned that it's looking quite promising to obtain funds in 2025 to conduct the actual execution of this HOS project, which includes the construction of the facilities, the operation during one summer, particularly summer 2026. We are expecting to run that for about 6 months between June and October, continue with the community engagement, and also conduct the post-monitoring. So essentially conditions while we are adding oxygen and after the oxygen addition. We are estimating that this phase will last around 2 years, starting spring 2025 and finishing spring 2027. So with that, I would like to wrap up this talk with some take-home messages. Hypomagnetic oxygenation, or HO, is a potential technological solution to clear lakes' water quality challenges. The direct injection of pure oxygen near the sediments is essentially what this technique is doing, with the ultimate goal of reducing internal loading of nutrients and also their contaminants, such as methylmercury. And our tools developed during the last few years for in-lake modeling confirm that the pilot project in the Oaks Arm will be successful and capable of treating 10% of the lake surface area. Again, this is a significant portion of the lake, and I would like to put that into perspective compared to other restoration strategies. This is the largest surface area percentage compared to others. And HO, because the ability of treat large surface areas in a large lake is a potential solution for the whole lake. Finally, a quick note about funding. CNRA has already funded the planning phase of this project, and we have ongoing conversations with US EPA for the execution phase, which is essentially construction, injection, and post-monitoring. And with that, I would like to thank everyone listening this talk. Thank you all the tribes and all our collaborators for letting us do this work in your land. Also, thank you to our funding agencies. And here you can see our website at clearlakerehabilitation.ucdavis.edu, where you can find more information, our data, and our projects. So thank you very much for your attention. And if you have any questions, please reach out anytime. Thank you. Bye.